英語苦手なんで日本語でちょっとだけいきますが、ごめんなさいね。こっち側、I'm sorry for Japanese speaker。こっち側に同時通訳を聞けるエリアを設けています。同時通訳で、ここからもう、キーノートの間だけ同時通訳になりますので、こちら側に一番行ってください。同時通訳の機器は最後に絶対回収なので、絶対持って帰らないでください。よろしくお願いします。ということで改めまして、Welcome to PyCon Japan. I am Manabu Terada, Chairman of PyCon JP 2012. We are starting PyCon JP now. This PyCon theme is Python Connect. This means making relationship worldwide. We have 2 days, 3 simultaneous sessions with 4 different Python application communities and 3 hands-on. And we have 1 day sprint. The purpose is team development and or hands-on. We would like you to enjoy the conference and participate in many sessions. I would like to introduce our attendees. Those people from overseas, please stand up. Overseas, from overseas, 海外からお越しの方お願いします。Please overseas. Thank you. From Europe, please hands up. Please Europe. From London, keynote speaker. From North America. From North America. Oh, thank you very much. 2 people. From Singapore. From Singapore. Thank you. From Australia. Oh, okay. From Taiwan. From Taiwan. Thank you very much. Are there any other countries? No. Okay. Thank you very much. Now for Japan. Okay. From Kanto, Tokyo and Kanto area. From stand up. Stand up, please. Please stand up. Thank you. From North Japan, 東北 and 北海道。東北とか北海道から来ている方、お立ちいただけますでしょうか。Thank you. お二人いらっしゃいます。ありがとうございます。Thank you very much. From 中部 and 関西、関西エリアと中部エリアをたくさんお越しいただきましてありがとうございます。From West or South Japan、九州とか四国とか広島とか、その他沖縄とかから来られている方いらっしゃいますか。ありがとうございます。どちらからですか。福岡からありがとうございます。From 福岡。Okay, thank you very much. 全然回してないね。はい。はい、I'd like to introduce sponsors. Nifty provides Nifty Cloud C4SA. It is platform as a service that enables you to develop. Gold sponsors: Tengen, MongoDB, Gumi, Microsoft Japan, SQBism, Club. Silver sponsors and silver sponsors. Okay, thank you very much.
Good morning, Pythonistas. I'm Takanori Suzuki. I talk about precaution and program overview. First, eating. We do not eat into all conference rooms. We only eat in the cafeteria area. Second, photos and videos. Please note that we take photos and videos of the conference. Simultaneous interpretation. 同時通訳、日本語でちょっと失礼しますが、そこに同時通訳の場所があります。で、今日終わった後ですね、キーノートが終わった後に必ずレシーバーをスタッフに返してください。あの人です。あの人を見てください。あのカゴを持っている人に返してください。絶対です。よろしくお願いします。羽織るな。こっちは入ってない。はい。If you have any problems, please feel free to ask PyCon JP staffs. We are wearing the staff t-shirts. This staff t-shirts. As wireless LAN, the venue provides wireless LAN access without this main hall. This wireless LAN information has been noticed in any conference rooms. 重要なことで日本語で失礼します。このホールでポータブル Wi-Fi を使うのはあんまり使いすぎるとネットワークが全部死ぬので、ちょっと様子を見て自重をお願いします。はい、ワイヤレス LAN、WPA2 パーソナルです。and Web Authentication。ノーティスされているので他に。はい。Program overview. PyCon JP includes 2 days conference and 1 day sprints, and 2 keynotes, and 3 talks, and 3 hands-ons, and 4 joint events. And other topics. Company booths. Please look on the back side. There are sponsor company booths. ぜひお立ち寄りください。カンパニーブース。Lunchtime events. Today's lunchtime event is introduce the Python connected community. The venue is here. And recruiting session. これもまた日本語で失礼します。明日、リクルーティングセッションっていうのが行われます。日本の方向けですね。で、スポンサー企業さんが企業紹介 LT と、その後必要であれば面談ができますので、直近ではなくても Python での仕事を探している人はぜひぜひご参加ください。And job board. There are job offering and job hunting board next to the reception. Open Spaces. Open Spaces is on tomorrow afternoon in all rooms. Please enter what you want to talk to the whiteboard. Let's build sessions or attendees. This is Open Spaces whiteboard image. Please write to the sticky notes that you want to talk. And please attach to your sticky notes on the open spaces on a whiteboard. Why open spaces? Rather than just listening, talking is better. Rather than just talking, collaboration is more better. This is first collaboration time. Let's conversation with your neighbors. お近くの知り合いじゃない人とお話をしてください。どうぞ。Let's conversation with your neighbors. Go ahead. Let's conversation with your neighbors. 知り合いじゃない方と。アーミンと話してください。でもうちょっとしたらアーミンを呼んでください、はい、こっちは送ります。
もう送るの？
うん、だってよし、仕事終えたら
準備して私が紹介するのでモニターの準備してもらって
Sure. Just give me a second. Is it on? Test? No.
How far does this go?
Not very far.
Pretty far.
Not far at all. But it's a standard MacBook. Sure. Yeah, that's probably a better idea.
これじゃダメ。これ使えない。使えない。使えない。これ使う。それを頭を使う。
Yeah, it doesn't really matter.
これは使える。こっちは同じ。
It's the same. It's just different.
Voltage, yeah.
Not the voltage is the same. It's different power levels.
Wattage.
Yeah.
Like the wattage is different for these, so like the small ones you can't use them. Anyway, don't forget that.
Yeah.
Thank you. Okay. Our keynote speaker is Armin Ronacher. He is one of the founding members of the Pocoo team, a group of either Python developers responsible for the Sphinx documentation tool and Jinja 2 template engine and more. Recently, he developed the Flask micro framework. He is currently working for Fireteam, a game service company in London. それではお待たせいたしまして、私の拙い英語を聞いてありがとうございました。この後渡しますんでよろしくお願いします。
All right. Hello, everybody. My name is Armin Ronacher. I'm very honored being here as a keynote speaker. This talk was motivated by, well, my open source work to a large degree, but also by me helping people on the Pocoo IRC channel using my libraries and other Python projects. So I wanted to do a talk about not so much technology, but being a better programmer. And I have never done it so far, so this is my attempt to it. So my IRC handle is Mitsuhiko, which is from the Detective Conan manga. But I don't actually speak Japanese, so I'm sorry for that. Everything I'm talking about here, and I think this extends beyond the talk, should be taken with a grain of salt. I think people in general should always question what they listen to, and this obviously also includes this talk, which ironically is slightly in contrast with the topic of the presentation, which is why happiness matters. And why I talk about happiness? I believe that we can deliver high-quality products if we are happy people. So if we're happy, then we like what we're doing. Happiness is, in my mind, very important, because if you don't value what you're doing, you're not going to make something useful. It might work for a while to be an unhappy person and create a product, but I think it gets you grumpy and eventually it will no longer work. Happy people are, in my mind, productive people. And if it wouldn't be for happiness in software development, I'm pretty sure there wouldn't be any open source software. So people do open source software because they like what they're doing. And we definitely love Python. Many of us are using Python because it makes us happy, or at least more happy than writing it in some other programming language. Because what kills happiness in software development is often if you hit a wall. Something stops working and you have to do something about it. You have to fix the problem, but there is not much the computer is giving you in terms of information about how to solve the problem. In Python, that's often not the case. Even if there's an exception, you still get a trace back. You still see where the error is located. And the interpreter tends not to crash in the operating system itself. And there are no clever compiler optimizations that would make it hard to dive into what's actually wrong. But why does ignorance matter? And why is it sometimes important to be ignorant? And ignorance here is means, I guess, ignorance as in ignorance is bliss. And this might be quite controversial, but this is how I believe part of happiness works. If we're children, we start being really ignorant about everything around us. We're kind of naive. We don't see the world as it really is. We think everything was rose tinted eyeglasses. But then we get to school and we're being educated and we learn more. And we're becoming more aware of what's happening around us. Then when your education continues and when we start working, we learn even more things. And this is a process that never ends. But as we become more and more educated, we start to no longer, well, we stopped exploring to some degree. We stopped being, we stopped trying something. Instead, we would pick up a book and we assume that someone else has already done it. And we see how much work is involved. So we just read up on things instead of actually trying it. And eventually we will worry more about things. There is a lot more stuff that can go wrong, and a lot more things where it might intimidate us to even start doing something. So in my mind, ignorance is bliss to some degree, because you need to stop worrying about a whole bunch of things in order to be happy, in order to get anything done. And ignorance and dedication gets you incredibly far. And here's an example from this. There's a company called Wallfire. They did a game called Lugaroo, and they also run the Humble Indie Bundles, which you might know, which is a website that sells indie games to a price you name. So you go to the website and you can pay an arbitrary amount of money to get certain games. But they also did a game called Lugaroo a while ago, and it was a game released for Mac and later became part of the App Store. And it was also eventually open sourced under the GPL license. And why am I talking about this game? Well, first of all, you have to know what the game is. It's a 3D game. It's a 3D platformer, sort of. It's a ninja rabbit fighting game. And this is a screenshot from the game that was released, I think, maybe 2004 or 5, something like this. And this is the current game they're working on, which is like a new iteration of the game with better gameplay mechanics, and it looks much nicer. But why am I talking about this? Well, I'm talking about this because the code is open source. You can have a look at it, and the code is it's actually incredible. So how many of you develop with C or know how C code roughly works? This here is an example from the C++ source code they have. What this is doing, it has the word screenshot, and it tries to put it into a string, but they do it by assigning every single letter, one after another, into a string array. This is like a very inefficient way. If you would know how the language works, you wouldn't do this. And they have an even more impressive function in there, which is the game tick function, which does all the things. It declares all the game logic, it handles all the gameplay sounds, it handles networking code, the main menu. It does collision detection, it does the movements, it does the input validation, everything. There's a function of 10,000 lines of C++ code. It is executed every single frame. And it has up to 12 levels of indentation. My point is, they made a really successful game. They didn't know about software architecture or anything like that. They just wanted to make a game, and they made it work. And they became good programmers as a result of that, because they eventually learned what they were doing. But with everything I know about software development, making a 3D game would be a really intimidating task, because I would see so many things that can go wrong every single line of code you write. But they didn't care. They just started making a successful game. Because there is so much information out there that it's really hard for us to get started somewhere. It's really intimidating. You want to make a website, where do you start? Like, there's so many technologies and buzzwords, and everything wants your attention. So depending on what you want to do, chances are it's a really intimidating thing. And very often, people start somewhere by picking a technology instead of starting doing it, well, to some degree from scratch, I guess. And if you're done with the project, it might be that the technology used is no longer what someone would tell you to do. So the way Wildfire did it and the way many people still learn software development is to just do it step by step. And I think in general that's a really, really good thing, because it doesn't really matter where you start for as long as you actually start. And by actually start, I mean not reading up on how the technology works, but by getting your hands dirty, actually doing it. And if you have a quick iteration cycle, every small step is an achievement. And that makes you happy because there is a progress you can see about yourself. And the best part about doing something step by step and learning something from scratch is that you learn to love and hate certain technologies on your own, and not because someone else told you that something is bad. Like Hacker News, if you read the website, will tell you on a daily basis how PHP is the worst programming language in the world. I mean, you can take the word for it, or you could experience it firsthand. And sometimes if you experience firsthand that something is a bad technology, you will still see that certain parts of it are actually quite good. Like C++ gets a lot of criticism from people for being a complex and wrong language, but there are still certain aspects of the language which are good. So I guess it takes a healthy balance. So just because you start ignorant, you don't stop there. But it might be a good idea to every once in a while step back and ignore all the problems that could be there and want to be solved, and just ignore them. One of the concepts that I don't actually know who coined the term, but is cargo cult programming. So cargo cults were, to some degree, tribes that there were, when the Spanish came to new continents, they brought a whole bunch of things that the people that were living there didn't know about. And they didn't understand how they would work, so they would worship them as things by the gods, like gifts by the gods. And this term cargo cult eventually entered software development as well, as the concept of you just take something and you use it without understanding how it actually works. And if you do a presentation about how you created a certain product, a question that comes up very often is, why didn't do it this way? Or why didn't you use technology X? And that is probably, in my mind, the worst question you can ask after a presentation, is because very often the question is just inherently wrong. The answer most likely is it wasn't considered. Like, there was no reason for us to do this. We just didn't do it this way. And this is something that many people don't understand. Like, Node.js is the thing you have to use because it's so much better than, I don't know, blocking C code. But if blocking C code works for you, then there was no reason to look at Node.js. Or very often you can find a theoretical computer scientist telling you the complexity of the algorithm it's too complex. You can do it like in constant lookup. But then there is theory and there is practice, and every once in a while, something that is nice in theory is actually not at all nice in practice, because it comes with a lot of overhead, or it only matters for really large numbers of n. And especially in computer science, very, very rarely is n actually infinite. Like, very often is n actually capped to a certain size. And then if you think closer about it, then there is n is actually constant numbers, so everything looks completely different. Or one thing you find in the gaming industry very often is scripting languages are slow. You can't program computer games in it. And then you look at one of the most expensive and the most well-known gaming engines, which is the Unreal Engine. And you would be surprised to see how much code in there is written in their own scripting language, which, as far as I can see, is not any way faster than Python. But the reason why Python isn't being used in the gaming industry all that much, but performance is not really the reason for it. If you look at the real world, there are some really good examples of how complexity kills happiness. SOAP is, I think, one of the best examples there. It stands for Simple Object Access Protocol. That's what it stood for until a couple of years ago, when people realized it's neither about objects nor is it simple. So now it has no meaning at all. It's just SOAP now. And it's a very complex protocol. It's not fun to work with. And if you use it, you don't even realize what exact problems it's trying to solve. Or something I had recently to deal with is SAML, which is security assertion markup language. It comes with a whole bunch of buzzwords that will tell you it's secure, it's the thing everybody uses. But if you actually look at what problem is it trying to solve, it is basically a more complex version of OAuth. It tries to sign you into website A, and then when website A wants to figure out if you're signed in, it will not do it by looking at its own user database. It will ask website B for your credentials. So it's basically you sign in one website, and another website can take over your user authorization in a very secure way. The Wikipedia article for this says, SAML 2.0 is an XML-based open standard for exchanging authentication, authorization data between security domains that is between an identity provider and a service provider. What it actually wants to tell you is it's OAuth, just more complex. And then you look at the specification, and it's SAML, it's XML, it's XPath, XPath filter, XPointer, XLST. You have to speak HTTP, there's XML encoding, there is X509 security certificates, there's XML DSEC, there's canonical XML. And then you take all the specifications one after another, and you end up with thousands and thousands of pages. If you try to implement this from scratch, you would be the saddest person in the world. It's really hard to do. And then what do you actually gain from it? It doesn't make you happy. It doesn't solve a problem, because what it's actually trying to do, it tries to sign in. But because SAML is so complex, there are a lot of companies being, pure existence for some companies is to sell you SAML-based solutions, because it's so expensive to do yourself. You kind of have to buy something else's. But if you actually look at the problem, what are you trying to do? You're trying to transfer authorization data from website A to website B in a secure way that nobody can steal it. And so what you're actually doing is you have a shared secret, you have a message authorization token, and you have an encapsulated payload, your user ID. And then if you look at how much Python code would this be, it's, I don't know, 20 lines of code maybe? That's your own SAML, no XML. Is it secure? There are definitely some problems with it. Like the way it verifies the signature, it's not resilient against the timing attack. But would you know if your SAML implementation is secure in that regard either? Like a lot of the security that people tell SAML has is you don't even come to discussion security parts, because you have so much XML crap on top of that you just have to start with the XML security analysis first. And there's some really interesting attacks against SAML as well, which people don't even know about, because there's so much complexity involved that they don't care. But if people see this 20 lines of code, they will start attacking it left and right, and they will try to punch holes into your problem. Yeah, is it secure? It takes 10 minutes to implement. You know what it's doing. You can see the security problems. There's a timing attack in there, which you could fix. But really, would you know if SAML is more secure? There are other examples as well. In the Python community, we have this idea of we want to have pluggable applications, where you make a small part of an application that you can use in different places. And the more we're trying to solve pluggable applications, the more problems we find with it, where this doesn't work, so we have to put another layer of indirection on top of it. We end up with systems that have the complexity of Java 2 Enterprise Edition. And then you look at Django, which has a very naive implementation where there are a lot of problems with it, but it's incredibly popular and it's so easy to use. Just compare your average SOAP application against your average Django application, and you can see the difference in complexity there. And then I think most people would just say, unless they know SOAP so much, that they would enjoy programming in Django much more. PHP, I think, is a good counterexample of that. It's barely a programming language. It has a lot of flaws, but it's hugely successful. And it's so successful because it's so easy to learn. It's so easy to get started with it. It's very fast to do small steps. You can make your hello world in a line of code, assuming you have Apache installed. And if you look at how many people have no understanding at all about what they're doing in PHP, and they still get stuff done, it's quite interesting. People are criticizing C every once in a while about how the language is impure, how it's not functional, how it doesn't have objects, how there is no type safety, how the standard library is bad. But it's the pillar of software development. It's a very simple language. You can implement a compiler yourself if you want in maybe a week, and it will work. It's a simple language. It has its flaws, but that doesn't hamper its adoption at all. The last part of the presentation is personal guidelines I found that worked for me. And this comes with a huge disclaimer, which is, this is personal experience, and I haven't done nearly enough of this thing to be able in the position of telling other people what to do. So take all of this with a huge grain of salt. One thing I noticed that happens very often on IRC is that people ask the wrong questions. Because they already started going down the route which they wanted to go down. And then they start a question halfway in it, instead of asking the more important question which they should have asked a while ago. For instance, people would ask, how do I use G-Event with Flask? G-Event is an asynchronous programming library, and Flask is a micro framework. But what they actually should have asked is, how do I notify my web browser in real time about events happening on the server side? Because that is the problem they want to solve. But they already decided G-Event and Flask would be the solution. So they already started traveling down that road and now ask against specifics of their problem solution instead of discussing the actual problem with someone else. Like, if you would want to do a computer game and you would start, how do I program a computer game? It's a better question than, why do I download Unreal Engine? This is a pet peeve of mine, which is avoid global state. And I think that is the only thing you should probably take away from this presentation is, if you can avoid global state, just avoid it. It's easy to do if you start from scratch, but it's impossible to integrate afterwards into a library. And that by itself has nothing to do with the presentation, but you really should take this as a pillar stone of modern software development. If you're done with the iteration step, say you develop something for 2 weeks and you delivered something and it works, it's a very good idea to go back over the code and see if there's some simplifications you can make. At least to try to learn about problems you have solved along the way you didn't think about, or to improve upon what you're doing. And then try to see if you can simplify the implementation. And very often this will show that there are bugs in the implementation you didn't think about. If you just write the code once and you forget about it and then come back half a year afterwards, it's probably not a very pleasant experience. You probably won't feel very happy about it. But if you double check everything you have done after 2 weeks, then chances are you will actually end up with something that you still keep in mind 6 months from now, if you're going back. And maybe even look at the older code and try to improve it just to see how much better you've become as a programmer. Because if you go back over a project you did a year ago and you see you actually improved, then that is something you can measure. That's something that makes you happy. If you just look over old code and has the same quality than code you have now, then you don't see an improvement. That can be a very frustrating experience. And this is, I guess, the last thing is, what makes me happy as a programmer is if I use a library and the library is not getting in my way. So if I have to make a library from scratch, I will try to approach it from the side of being a user first. I will try to use the library I didn't even write yet to see if it would make me happy. And if I like the experience of my made-up library, then I would start the implementation. But I wouldn't implement it first and then afterwards discover that what I made was really, really bad and is not at all in any way what I want to do. Yeah, this is basically my presentation. And I have, if people are interested, I have a lengthy, I have enough time to do proper questions and answers. And as far as I understand, there will be translations for questions. So if you want to ask in Japanese, I should be able to have a translated version of that question if I would find the translator thing. All right, we can start with English questions until I find until someone brings me the headphones. All right, thank you. If someone wants to ask a question, just go ahead and we will try to get a microphone into the audience. Otherwise, just shout and I will try to repeat the question.
Yeah, I think you make a great point about happiness in software development. But my question is about, is there any possible or viewable means to quantify the value of happiness? Because that will be important to a normal programmers to take this topic to a corporation, so that if we can quantify the value of happiness, then it will be easier for a normal programmer or a normal developer to communicate with his management in a corporation. So do you think is that possible to do something like this?
Yeah, that's a good question. Can you quantify happiness? Can you bring it up in a board meeting and say, if we do this and this, the company would be better off? To be honest, I don't know. It's definitely a situation where I sort of have been myself, where you can see that certain things in a company don't work the way they should be doing. Like, you think you have the solution, but yeah, it's hard. I guess you cannot change other people's behavior. You can only try to make it better for yourself. And if you see that the way you approach software development is what you think is better than what the rest of the company is doing, maybe there is a way to talk to a person that is in management and try to give them, like, pursue them with, yeah, we should be doing this because I think it makes it better. But I don't think you can quantify it. It's the part where you need to, I know, it's hard.
Yeah.
You would have to be really good with people to convince them that what you're doing is right, because I think it's a trust thing. It's probably not something where I can put a label on and say, you do it like this, twice the productivity. I don't think the world works that way. But I would love to be proven wrong, and there is this magic thing you can do to make work environments better.
So you mentioned that starting from ignorance is sometimes where people start with their problems. When you come up against a problem that you don't know how to solve, what's your first step to solving it?
Depends on the problem. Like, very often you already have, sometimes you have an intuitive idea of where you could just try it, and then you notice that was completely wrong. But it gets you into the general idea, into the general process of trying to solve it, because you're doing something, you're thinking about it. And generally, I try to do that. Just start somewhere, even if it's a completely wrong solution. And very often, at least for myself, I notice I'm starting at a completely wrong spot, so it might take me 2 days to to realize that I was on the wrong path and then try to go back where I started with. But generally, my approach to problem solving is trying to have an inner monologue with myself, trying to ask myself questions: what do I actually try to do, and then just try it. It obviously works much better if you can break down problems by yourself into smaller pieces, and then you look at each piece individually, and then sometimes you get this intuitive situation where everything starts to make sense, at least to some degree, and that's perfect, because then you know what you're doing. It's not that you know what you're doing, but you know where to go. You don't. There's a progress. There's small steps. There's small achievements. If you manage to get into this flow of solving a problem one step at a time, then that's perfect. And sometimes it just takes changing the requirements, if you can do. Like sometimes you notice that what you're actually trying to solve is not really what you want to solve. A good example of what really made me happy for the company I work for currently is we wanted to have persistent connections to game clients. And all of our code base is written in Python, at least the majority of code stuff is written in Python. And if you're looking at hundreds of thousands of clients that want to have a connection, then suddenly you want to do asynchronous I/O in Python. And our code base was not at all written for this in mind. So we started doing something where, yeah, we could do it in Node.js. And I was looking at Node.js and was playing with it. And then, I have to connect to MongoDB to get to my authentication information. I need to do all these things, like a huge undertaking, and then Node.js looked no longer interesting. So what I started approaching the problem at a different point, where it's like, what do I actually have to do there? Like, do I actually have to have persistent clients that authenticate? So what I started doing is I was using Redis as a communication channel between the main code base, which does authorization, and the presence server. So you don't sign in to the presence server, so the presence server never has, like the one that has the persistent connection, it never has to do any authorization. So instead you authorize against the already written Python code, and then it puts a small ticket that has a 30-second lifetime into the Redis database. And then all I have to do is I have to, from my C server, connect to Redis, check if the ticket is there, and the ticket has remembered which user I signed in with. And then I'm authorized. And that solved the problem, but it was originally it was a hacky solution. And then looking at it closer, it's actually a really nice solution after all. It just required rethinking the problem. So I guess that's my general suggestion for this kind of thing. Try to solve it in different ways, maybe. Yeah. Oh, sorry.
I think your statement about don't use global state is far too strong. If global state was a bad idea, then Guido would not allow us to do it. Why do you think that global state is so bad, and why do you think that Guido allows us to do it anyway?
So why does Guido allow us to do it? It's basically because the language was written this way. Like that. There is this general idea that Guido has only perfect ideas, but I think that was not the best one. But why is it bad? So first of all, what's the problem with global state? The idea is that you have, what is state? State is that something is remembered. So if you pick up computation at a later point, you continue doing your computation where you stopped, basically. So you have the same state. But if you look at like say you have your average Python framework, and HTTP request comes in, you process the request, and it produces a result. The assumption is that if you do this more than once, you get the same result back, right? Like if you send the same request, which is supposed to generate the same data, it's supposed to generate the same result. What makes this interesting is that part of your request handling depends on information that is not stored within the function. In Python, in Django's case, for instance, there is a configuration object, a big one, that stores certain information. So if you would modify this, your function would return a different result. And that is fine for the most part. I mean, I'm not going to argue that you should have none at all. But there are certain problems with this. A good example of this is if you try to solve a problem that requires you to have, let's say, more than one Django application in the same Python interpreter, both of them use the same configuration. So you can't have two different configurations, one for application 1 and one for application 2, because they use the same configuration object. Now what people start to do, especially if they're new to Python development, is they say, all right, fair enough, I can just, before the request comes in, I'm changing configuration to the way the application expected. And at the end of the request, I'm reverting the configuration back to what it is. But at that point, there is no thread safety anymore. There's a lot of problems that don't seem to be obvious. Like it works, why is it wrong? And then you look close at it, and then you actually realize that the solution I tried to do is completely wrong. And once you're down that rabbit hole and you already wrote a lot of code that depends on this, then you manage to maneuver yourself into a position where there's no way to go. You can't fix it. It's fundamentally broken. And that's a very, very sad place to be. So if you do a new project, it's a much better idea to, instead of saying this is a function, it does something, and on this, in the module that defines the function, there's a configuration object which you can modify. It's a much better idea to have a class where you pass the configuration in, and your function becomes a method of that class, because then you can have an arbitrary number of instances of that, and each of them works slightly different, and there are no problems with it. So I think that's the best part about object-oriented programming, that you can easily bind configuration and execution into an instance of an object. And unfortunately, Python was not written as a language with this in mind. For the most part, I think that's because that global state as a problem was only recognized when we started to do really concurrent programming, that there is something wrong. If you look at the C standard library, there are a lot of functions that are inherently just not the right way to approach something. And they actually became problems. They became huge problems. And now, if you look at the modern C standard library, there are a whole bunch of copies of the old function that were inherently wrong, and they now have an underscore R suffix, which fixes the behavior. But it does it at the cost of working differently. You have to change your code to do this. And once you're in the point where the global state became a problem, it's so costly and so frustrating to fix it that you really wish you would have done it proper at the start, because it's just a more pleasant programming experience.
Any question? 日本語でもいいですよ。日本語でも通訳しますので、英語で通訳できるので、日本語で質問されても大丈夫です。
じゃあすいません、日本語で、別々の2つのことをお伺いしたいと思いますが、一つは一番最初に、したプログラミングのことを教えてください。もう一つは、日本の好きなアニメを教えてください。
All right, the first question first. What's the first programming language I programmed? There was well, I guess it was Pascal. I picked up a book a really, really long time ago, and I just started making a small game with a friend of mine, and we eventually we won a small prize for this. And yeah, that was basically how I started programming. Or it might have been basic. I just found at one point I thought the idea was interesting and played with it. And in retrospective, I had no idea what I was doing, but I guess that's the point of it. In terms of what Japanese animations are like, I think I saw all of these Studio Ghibli ones, and I really enjoyed them much. And actually, if you I don't know if this is actually connected. If I start a new shell, this is what greets me. Also, notice the name of the machine is Nausicaa. So.
Okay. Any questions? 日本語でも。
Thank you for your interesting keynote. You talked about the programs which other languages have problems, didn't you? For example, no namespace, or no OOP, or throw, or no consistency. But how about other language? For example, Ruby. Ruby is not complex and simple, and have OOP. I guess that the Ruby is good driver of Python. Of course, I love Python. But what do you think about Ruby?
I was learning Ruby one of the Pocoo projects was Pigments, which is a syntax highlighter. And there was a guy in the German Ruby community, which had a really strong friendship with the German Python community, wrote a project, I think Raylight or something it was called. It was a syntax highlighter, and on the website he had like full Ruby compatibility. That was basically his feature set. And I was looking at this, and I didn't realize the complexity that was involved into proper syntax highlighting for Ruby. And since we also had a syntax highlighter, I really wanted to have a better version of that. So I started learning all these small little details of how the Ruby programming language works, because I wanted to have the perfect syntax highlighter for it. And I kind of fell in love with Ruby as a language for a while. I didn't do much in Ruby, but I was for a long time trying to convince people to have something like Whiskey in Ruby, and they eventually ended up having rack. And unless they change this, the logo for rack, I think, is still says copyright by myself on the website. So I did some experimentation with Ruby. I really like it as a language. It's just that it wasn't different enough to Python, which I had before. I guess that there was a reason for me to become more engaged with it, but it's definitely an interesting language, and it's fun to use.
Thank you.
Just kind of curious, like when you want to start a particular project, I mean, of course, when you work on the open source project, you actually just work because you want to do it, right? What if what do you usually do when you find out that, like, the project is actually not feasible to complete, or it's actually doesn't make sense? I mean, in the middle of the development or even planning.
Usually trying to figure out why, like, there comes this project which seems unfeasible or is completely unfeasible, and someone had this idea that this is how stuff is supposed to be done. I think it's an interesting experience to try to figure out why exactly you're being tasked in doing this, and then try to figure out what exactly that person wants you to do. I mean, it's a lot easier, obviously, if in open source development, because if you have this person I see that is trying to solve this particular problem, I will always try to play a mind game with him, trying to figure out what he really wants to do, and to try to convince him to do this. It's obviously a lot easier if you're an open source developer and someone asks you for help, and you steer him into a different direction because you think that it's actually what he wants to do. It's much harder in a company work, because the company guideline is we're going to do this, and then something inside yourself tells you this is not going to work, this is the wrong approach. So yeah, I think it's interesting because to some degree you still have, even in a very strongly regulated company, you still have certain ways to push things step by step into a slightly different direction if you come up with a really, really convincing argument for it. Or if you, like, when I see a really big thing that's not going to work, I will try to approximate the results and try to pitch this. Like, very often you can, especially in Python, you can make a really small prototype of something. And then you have ground to argue about you should be doing it something different. It's obviously, it's much, much harder if you're already down halfway through the project and you would have to throw away things. So at that point, programming becomes a little bit of a psychological game. But I mean, I personally, I do enjoy this quite a bit, so I don't mind going the wrong way. I take it as a challenge in that case.
I wanted to ask you, it's kind of about your talk, and so you mentioned that ignorance is bliss and that kind of thing, and so like and you mentioned that it would be good to step back every once in a while and like to like kind of reevaluate things in like kind of as if you were learning it for the first time. So like if you were doing something like that and like you kind of know a lot about the subject, but you want to approach it in a new way, like I don't think that it's as easy as just saying like, well, I'll just step back and not think about all those things that I know. Like, how would you go about doing something like that, or how would you think about it when you wanted to go about a project that way or think in a different way?
I guess one way to make this work, and that obviously depends on if this is possible or not, is force yourself into a different environment a little bit. For me, when I started working for the current company, I know a lot of Python, and web development and network and all that sort of stuff, but then you're suddenly exposed to people that do 3D graphics and real-time rendering all day long, and you realize how they come up with solutions that are completely different, and then you automatically start questioning a couple of things, and you start to reevaluate if something you're doing is actually the right way, because what they're doing, which is so close to solving the same problem but it's in a different way, there might be value behind that. So just I guess change of scenery, if you can make it work in any way, like looking at a different programming language or something like this is definitely it's sort of an easy way if you have the chance. Otherwise, if you have to force yourself to rethink things, that's I don't know. That's probably differs from person to person how you can do this. I sometimes have a really hard time to refocus, so I would just try to put the problem away for a while, and then maybe a solution comes up by itself, or at least a new way to think about it. Oh, actually, there is something else. If you ever have the chance, and I think that is probably one of the best things in retrospective I've ever done, is teaching other people on REC channels is perfect, because they will ask a whole bunch of questions, and you can. They basically come up with small riddles. At least you can look at it this way, and you can try to help them solve that problem. And very often this yields some interesting insights, or at least it gives you a new way to look at things. So teaching other people on the internet is generally is interesting. You can do it on Stack Overflow or something else as well, but just working with other people in your free time on things, it's definitely one of the best things I've done.
マイク誰だろう。マイク誰だろう。あ、池さん。池さん。マイクすみません。
普段使っている Python のバージョンとできればそれを選んだ理由っていうのを教えてください。
I'm using currently Python 2.7 on a daily basis, the standard C Python interpreter. Oh, the question was what version of Python am I using on a daily basis, and why did I choose that version? So we're using Python 2.7, and I'm also using that as for development on most of my libraries. And there are two obvious alternatives to this. One of them would be using PyPy, and the other one would be using Python 3. For a large degree, the reason why I use Python 2.7 is inertia. I did it before. It works for me. I know all the problems with it. I'm more productive with it. I every once in a while look at Python 3, and it makes, that's I guess sort of wrong, but it makes me unhappy because I always find new problems I didn't have with Python 2. So a large degree of why I still use Python 2.7 is just because it feels so much nicer for me knowing the language. Why am I not using PyPy? Same reason really. I do iterative development, so I run my test suite really, really often. And the Jinja 2 test suite takes 2 to 3 seconds on Python 2.7. Because PyPy is a JIT interpreted language, and each of the tests it runs exactly once. The JIT never has the chance to get warm. So running test suites with PyPy is really slow. I think the Jinja test suite might take like 20 seconds instead of 2 to 3 seconds. I think that is the main reason why I'm not using PyPy more. It's just because in the way I'm working, a JIT interpreted language is not fun.
はい、オペレーション、またマイクお願いします。
Now the Python 3.3 is going to be released in the near future, and then since from the Python 3.3 the language moratorium is ended, and then the new feature is coming to the Python stable release, and then what do you think is the most difficulties of switching from Python 2 to 3?
So far the biggest problem I had with switching was the fact that you can't have the same code base for 2 and 3. That was largely resolved now, so you can definitely have the same code base running in Python 2 and in Python 3. And the reason why I never really liked the idea of 2 to 3 is the same reason I really don't like PyPy as a daily development environment. It takes a minute to run the translation to Python 3. So if you want to target 2.2 and 3.0, or 3.x, then 2.x and 3.x, then 2 to 3 was never a good tool because it was very annoying to use it. It was just not fun. Now, what blocks me for the most part is that like some of my libraries don't work on Python 3 at all right now, and that is partially because some decisions I made in the language in the library design was to improve Unicode support, and the way Python 3 started approaching Unicode was different than I started supporting Unicode in my libraries. So it's a breaking API change slightly to go to Python 3, and I didn't have enough reason yet to migrate to Python 3. But it's definitely, if you make a new project, it's definitely possible to target them both. I think it's still, for me personally, there's still, I guess, not enough reason yet to go to Python 3. It will definitely happen eventually. It didn't happen so far. That's, I guess, my answer for this. All right, the next question is the last question.
Hi, just want to ask one question. What if you are like asked to take over like an existing project where the code is actually functioning well, but it's not well written. It's like full of spaghetti code or whatever. Would you like try to try to try to clean up bit by bit and try to as long during the maintenance you want to clean up the code bit by bit, or would you rather like overhaul the whole system, like trying to write it from scratch using your favorite programming language, for example Python? What will you do?
Depends on how the application is structured. If it's like a web style application, which you deploy in a server and then someone else interfaces it through socket or HTTP or something like this, then the way I would go about this is I would start writing new features with new paradigms, maybe a new programming language, and I will try to make my communication channel to the old app to start writing new things in a new part, and then eventually phase out more and more stuff from the old application. That's, as far as I understand, also how Mozilla eventually migrated off their Drupal installation for add-ons Mozilla. They started writing more and more things in Django. If you have like an application you deliver to customer, that might be much harder because now you're adding more complexity that needs to be installed. And never having done that thing, I don't think I would have a proper answer for it. I would probably just try to take it as a challenge for myself, because there has to be something rewarding in it. And if it's eventually just you no longer have the old spaghetti code around, then that's definitely an accomplishment you could be proud of. So I would probably try to make it work in some way. But personally, I would have a look at it and then try to figure out what's the best way to sort of, in quotes, clean up the mess. All right, thank you.
Thank you very much, Armin, Mitsuhiko. Next session will start 11 o'clock. We have five sessions. This is also main session, and other is reference is this book.
And I have two things about the T-shirts. First, you will be able to get the general T-shirts or sponsored T-shirts in entrance floor at lunchtime. And second,
T マークがついてる人だけ。
sorry, only T mark. You have a T mark.
T マークの理由は8月末までに。
それは知らない。And the second part, you will be able to register lightning talk speaker at the entrance floor too. That's all.
Thank you very much.
すみません、これで移動していただいて構わないんですけれども、翻訳機を持っている方だけは、回収をしなきゃいけないので、これから係の者が向かいますので、そこまでお待ちください。